Okay, in this video we're going to be looking at how to take the derivative of inverse functions. And there's a few things about inverse functions that you need to review that you've seen in previous classes. Okay, so sometimes you need to be able to find a function's inverse algebraically. So if you change f of x to y, and then you switch x and y, so in other words you're switching the input with the output, then you solve for your new y. And now, since it's an inverse, we use this little -1 looking symbol to call it the inverse. So that's how we algebraically have found some inverses before. Okay, if you have a point on a function, you need to know that switching x and y is how you get a point on the inverse function. So for every point given to you on the function, you know a corresponding point that would end up on the inverse function. If two functions are inverses of each other, that means like the inverse of f is equal to g and the inverse of g is equal to f. So just really some notation there. It's not possible for one to be inverse with the other and the second one not be inverses with the first one. And then sometimes we need to show it algebraically. So if you were to plug one of the functions into another function and simplify it, and if you did that both ways will simplify to x if they are truly, in fact, inverses of each other. So you've seen all those things in previous courses before, but it is helpful, and I'm going to be using some of that in this video. So you might want to pause here and make sure that all of that sounds familiar to you. Alright, so in calculus we say if we've got two functions, f and g, if you want to take the derivative of the inverse function, this is one way to write that, and there's a second way. So as long as you're calling them f and g, then this should say inverse here. You're taking the derivative of the inverse. If g and f are inverses, then you can think of it this way, but then you can also use it this way as well. So this, I kind of like the one on the right, and that's the one I'm going to stick to, just because it's less stuff. So some questions might talk about h and g, or g and f, or f and h, and it just removes confusion for me. If I know whatever I'm trying to find here, I'm just going to say it's its inverse, and then the other one on the outside here. So if you're interested in where this comes from, then please follow these steps. That's not something that you really need to know for this class. You just need to know the formula and be able to manipulate it a few different ways. So let's look at an example here. Let's say we started with this function. Here's f, and we are trying to find this. What is the derivative of the inverse of f, specifically at 3? Alright, well remember, the x value on a function is the same as the y value on the inverse. So if we set this equal to 3, so notice this is like, what we plug in, we say x, but I'm plugging it in for y. So inverses swap it, x and y, so I'm swapping what I'm plugging it in for. And then I have to solve this. I have to figure out what values of x make that true. Well, that's not something that you can do by hand easily, if at all. So I use the equation solver on my calculator, and so you should practice using that, because that would be a good strategy here. You get x is 2. So what I really figure out here by plugging in 3 into y is that the function equals 3 when x is 2. Okay, I set y equals to 3, and I solve for x. So this is what I used the function, so that's what I got. Now, very important, you understand where this is coming from. Inverse, you just swap x and y. So now I also know if I plugged 3 into the inverse, I would get 2 as an output. So x and y are being switched here. Okay, so now that I know that, I can use that formula from right here. I'm going to refer to this one. So if I want to know the derivative of the inverse at 3, plug it in, the formula is going to look like that. And notice, this is why I did this work here just a second ago. Because I know this, I can substitute 2 in for all of that. So now I know the answer is going to come from 1 over the derivative of f at 2. Okay, well, I've got f up here. I can easily take the derivative, the power rule a couple times, and then I can plug in 2. That's messed up. I can plug in 2 to figure out that that equals 4. So if the answer was 1 over the derivative at 2, now I know it's 1 over 4. Okay, so let's look at this question a little bit more in depth here, so you can try to understand what's going on, and you'll catch up, or the next question will make a little more sense here. So from here, I just plugged in the formula. Okay, so I have to know the formula to be able to do this question. To know this was 2, I had to use my background knowledge of inverse functions. If I want to plug 3 into the inverse, that's the same thing as setting the function equal to 3. X equals 3 on the inverse is the same thing as y equals 3 on the function. So I did that, let my calculator solve. It told me that happens when x equals 2. So in the function, if x equals 2 gives me a y value of 3, then switch those around, and that's where I got this, and I was able to plug that into there. And then from there, you need to be able to take the derivative and plug in stuff, but that's much easier. Okay, so let's look at another one, and then we'll pause and have you try it out and see where you're getting stuck. Okay, let's say I had this function, and I wanted to know the derivative of that function at its inverse when x is 26. Alright, so if I'm trying to plug an x value into the inverse of 26, that's the same thing as plugging a y value into the function. And so I don't need a calculator for this one. I could add 1 over, take the cube root of both sides, and that happens when x equals 3. Alright, so this step, I'm about to use this information here. You really need to understand why I'm doing those steps. So what I just figured out is plugging in 3 for x gives me a y value of 26 on the function, which means I could swap those around, and I can tell you that plugging in 26 into the inverse is the same thing as giving you 3 into into its inverse. Okay, so now we can say, all right, if this is what we want, this is what the formula says. We now know that this is 3. So 1 over the derivative at 3. So here's the derivative. You actually have to apply the power rule to find the derivative. Plug in 3, and since it was 1 over, we get an answer of 1 over 27. Alright, so if you would, go ahead and pause the video, try question 1, and see what you come up with or see where you get stuck at. Alright, so this time I'm actually going to start right here near the end. If we're trying to figure out the derivative of the inverse at x equals 2, then the first thing I'm going to do is I'm going to just plug it into the formula. The formula says 1 over the derivative of the inverse at that x value will give you what you need. Okay, so I can do derivative later, but I got to figure out what can I plug in. I need to change all of this into a number. So plugging in 2 into the inverse is like setting the function equal to 2, and x in the inverse is the same as the y for the function. And then I need to figure out where this equals, or when this is true. So I'm going to go to my equation solver. That doesn't look like it. One that's very easy to do. So when does 2 equal x to the 5th plus x? Of course, you should only do this when it's not something that's easy to solve. Okay. Alpha, enter. All right, and then notice it changed that to a 1 for me. Well, if that was a 1, maybe that wasn't so hard to solve. I didn't think I would get it, but so what I just figured out is in the function, 1 for x gives a y value of 2. That's important because now I can use this information, swap those around. Plugging 2 into the inverse gives you an output of 1. Okay, so to me that's the trickiest part, but unfortunately that's the part that we're supposed to be pretty familiar with, seeing inverses in our other courses. But now my answer is going to be 1 over 1 plugged into the derivative. So I'll take the derivative here, power rule, let's plug in a 1. And so we get 1 over 5 plus 1, which would be 1 over 6. So if you got choice D, then good job. Alright, so now would be a good time to pause the video, look at where you got stuck maybe, and try to learn from your mistake and see what you need to do differently. Okay, and then after that, if you would, after you've learned from your mistakes, go ahead and try number 2 and see if you can get a little bit further this time. Okay, so for question 2, I'm going to just change these to F because it really doesn't matter and it fits my formula a little bit better. So my formula says if I want to know the derivative of the inverse at 2, that can be found by doing 1 over the derivative of the inverse at 2. Okay, so the first thing you got to figure out is what is 2 plugged into this function. Alright, so we could, I guess, find this inverse function by switching x and y and trying to solve for y. That's not going to work out for you though. So instead, we got to think about 2 as an x in the inverse. It's the same thing as 2 as a y for the function. So I'm plugging in 2 in place of y. Okay. Now if I subtract that over, now we get 0 equals x cubed plus 2x minus 3. And only if that was a quadratic, I'd be able to factor that pretty easy, but it doesn't look like that one's going to solve very nice either, so let's not stress about it. Let's let our equation solver help us out here. X to the third, whoops. Plus 2x minus 3. Okay, now you might think the answer is 1 from a minute ago, but you actually have to hit alpha enter to get it to change. Oh, well, alright, so what are the odds of that? It's actually stayed 1. I didn't think it updated, but I'm plugging it in. 1 cubed plus 2 times 1 minus 3, that makes sense. So 1 is the solution to that. So what I just found out on the function, when 1 is x, y was 2. So if I switch those around, I know in the inverse, when x is 2, y is 1. On the inverse, when x is 2, y is 1. Okay, now I need to figure out the derivative and plug 1 into it. So it looks like I could do the power rule, and the derivative of the constant is 0. So we end up with 1 over 3 plus 2. So I'm getting 1/5 for question 2. Okay, we've got one more of these for us to try. And again, I really think you should probably pause, try to learn from your mistake in number 2, and see if you can avoid that in question number 3. Alright, question number 3 gives us a little more information, which in some ways kind of makes it easier, but it doesn't look exactly the same, so we have to be a little careful here. So I know this is going to equal this. Again, if you really want to understand where that comes from, remember on the front page here, I didn't take time going out over here, but I have the steps where you can see where it comes from. Okay, so I need to know the y value when I plug 5 into the derivative. Well, if 5 is the output in the function when 4 is the input, that means you can plug in a 4 there. So that's how they're using this to get you that that is 4. Okay, switch x and y switches your point from being on the function to its inverse. Okay, and then you would need to know the first derivative at 4. So no coincidence, they gave us that information. And so 1 over 2 over 3, flip that around, that's the same as 3 over 2. Just go ahead and divide your fractions if you're not sure where that's coming out to be. So a different way to ask the same thing, and you know the AP test kind of likes to do stuff like that. All right, last part of our notes here is we need to memorize the last little set of derivatives. And so that's going to be the inverse derivatives. I gave you a handout, a table of derivatives, so all 6 of these are already on there. But I kind of rearranged them where they make sense to me. So I'll go ahead and explain that. Now when we look at these derivatives, you need to remember that arc sine is the same thing as inverse sine. Those are completely interchangeable. All right, well if you look at these two, arc sine versus arc cosine, their derivatives are exactly the same, except this one has a negative on it. When you compare arc tangent to arc cotangent, again, same derivatives, but this one has a negative on it. And finally, arc secant versus arc cosecant, also a negative. So always just kind of remember the ones with the C have the negative, and the ones that don't start with the C don't have a negative. And if you remember in pre-calculus, your cofunctions, sine and cosine are cofunctions, tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. That can kind of help you remember which ones match up together. All right, so if I simply wanted to know, and of course chain rule applies all the time now. Without being told, we have to use the chain rule. So if I wanted the derivative of inverse cosine of x, then I'm just plugging in x into this one up here, and it's already got an x plugged in, so no difference here. Okay, but if I plugged in a 5x, so everywhere there's an x, I plugged in 5x, this would be 25x squared. And now, this is like the inner piece here, so we have to also multiply by 5. This is really just using the chain rule. Okay, let's try inverse sine of 1 minus x squared. So we would need to know what that looks like. I want to memorize that. And then this is what we're plugging into x. Okay, and then that's almost our answer here, but the derivative of the inside is negative 2x, so we need to multiply by negative 2x for chain rule. Okay, let's. The most common ones here are sine, cosine, and tangent. Technically, you're responsible for knowing the others, but the other 3 are the big ones. Okay, so this time let's do 3 times the derivative of inverse cosine at x squared plus 0.5. Okay, well, inverse cosine looks like this, and then we're inputting that, and so that's all we have to do, except for we also have to multiply by the chain rule. So the derivative of the inside would be 2x, so don't forget chain rule. Don't forget the 2x. Chain rule, very important. Otherwise, it's just a matter of memorizing those. So these aren't actually all that difficult once you memorize them. But so before we finish up here, go ahead and pause and try to apply the derivative of inverse tangent to question number 8 and see if you can come out with the right answer. All right, so derivative of 4 times inverse tangent, and inverse tangent is usually 1 over 1 plus x squared. Again, this is one of the most common ones that the AP test likes to ask, so make sure you know this one for sure. But instead of x, we're inputting 3x to the 4th, and so I would probably go ahead and just multiply the 4 over, of course. And then if I square this, this would be like 9x to the 8th. And if you get that, you're pretty close, but unfortunately, you forgot the chain rule. So chain rule, this is the inside part here. Chain rule is 12x to the 3rd. So the answer you needed in the end would be 48x to the 3rd over 1 plus 9x to the 8th. That's what you're aiming for. Alright, so for this lesson, even though the derivative of inverse functions are not all that important, to even have a chance at doing those, you need to make sure you know this formula. And then you'll also need to make sure you know chain rule, as always, and make sure that you know these 6. And I'd probably put a star by sine, cosine, and tangent, because those are by far the most common ones. Alright, so that's going to be it for this one.